Benjamin here. It's our second show of 2025, and as we kind of stare blinkingly into the new year, we're going to continue our tradition now, 3 years running, maybe 4 actually, of talking about some of the science stories you may have missed over the past few weeks. And joining me once again to do so are Noah Baker. Noah, how are you?
I'm very well, thank you. Ready for the new year. Excited to look back on the very end of last year.
Excellent. And senior editor of the Nature Briefing, Flora Graham. Flora, hi.
Hi, thanks so much for having me.
Not at all. Happy New Year to you both. Now, we got a few stories to talk about today. We're going to sort of cover quite a lot of ground, I think. But Noah, why don't you go first? What have you got to talk about today?
So I'm currently sitting in my partner's family home, which is where I was almost 5 years ago when the word hydroxychloroquine first came into my lexicon when we were producing Coronapod many years ago from a duvet fort. And I find myself in the same place now, post-holidays, before going back to my own home. And the story I have is about a retraction. In fact, the retraction of the hydroxychloroquine paper that first kicked off this in many people's consciousness, which was 4.5 years ago that was published. And whilst that retraction has happened, there's various milestones to note. This is the second highest cited paper ever to be retracted. And there's a whole load of extra knock-on effects that have happened as a result of this retraction and as a result of these investigations about other things published in this journal and other things published specifically by the lead author on this, Didier Raoul, to investigate ethics concerns around publishing from this particular institution and from this particular researcher.
And this was a hugely popular story among briefing readers as well, Flora.
I mean, it's just such a fascinating story. This fellow, Didier Raoul, is a real character, very litigious. It ties into so much of the politicization of the COVID pandemic. It ties into that time when we were so uncertain about what we were going to be able to do to fight this disease, what we were going to do to recover from the pandemic. Of course, giant retractions are always fascinating in and of themselves because there's no shame in retractions, as we've written about many times. But a paper like this, which is a real fall from the heights, you can't help be fascinated by the destruction left behind.
So this paper's been cited 3,400 times. It's a lot of citations for a paper. And I'll take us back a little bit to when it first came out. You're completely right, Flora. I remember at this time when we were so uncertain, we were clamoring for as many treatments as possible. And then there was this preprint that came out from Marseille's Hospital University Institute Mediterranean Infection. I have deliberately not used a French accent there because I think I would have massacred it, but I'm going to call that the IHU from now on. Published by Didier Raoul and various other authors, claiming that this anti-malarial drug, hydroxychloroquine, could be beneficial in reducing viral load. Now, after that appeared on a preprint, 4 days later, it was published in a journal, the International Journal of Antimicrobial Agents, the editor-in-chief of which was a co-author on the paper, I should add as well, although there was a statement later released saying that he had nothing to do with the peer review of the paper. And then at that point, it quickly rose to prominence. It was all over the news in the US. Trump famously tweeted or posted on what is now known as X about this, endorsing the drug, describing it as a game changer. And quite quickly, hydroxychloroquine became approved for use, off-label, I suppose, to treat COVID-19. But then quite quickly after this study was published, lots of concerns were raised about the study itself. So specifically around methodological problems, ethical problems, the timelines of recruiting the participants. And as these concerns were raised, there was investigations that were started. There was also more papers that came out which contradicted this paper. There was various observational studies that came up saying that they couldn't find any benefit of hydroxychloroquine. And this was all escalated. And it got to the point that whilst there was a lot of concern around the paper, there was a decision not to remove the paper, not to retract the paper. And the statement from the ISAC at the time, when they decided not to withdraw the paper, was, in addition to the importance of sharing observational data at the height of the pandemic, a robust public scientific debate around the paper's findings in an open and transparent fashion should be made available. So the argument was made that there was a lot of research that was happening. We needed access to all the data that existed. We needed a robust debate, and so therefore it remained.
And a robust debate, as you say, was had, and here we are.
Absolutely. To the point that actually in June this year, after further calls to have this paper investigated again, Elsevier, the parent publisher of this journal, reopened an investigation, and the decision has now been made to retract the paper. And there's a lengthy retraction notice. I'd encourage you to go and read it if you would like, citing everything from methodological concerns to ethical concerns. And also it should be noted that 3 of the scientists that were authors on the paper also asked not to be included as named authors on the paper also citing methodological concerns, questioning the analysis and questioning the conclusions drawn from that analysis. And so now the paper has been retracted. That's the 28th paper authored by Raoul that has now been retracted, and the 32nd paper retracted from the AHU, which he used to be in charge of. He is now retired. There are 230 other studies which also have expressions of concern raised on them right now. So it's quite a big story from an institution and from a researcher, and for something that was so impactful around the world in terms of the response to the pandemic.
I characterize this as an amazing story, but of course the impacts are very real and very personal for the many people who were perhaps treated in, less than ideal way, perhaps suffered greatly, perhaps lost loved ones, and also the kind of undermining of trust in science and in healthcare that this shenanigan kind of contributed to, especially in the United States, is having lasting effects.
Absolutely, and quite directly at the hype around hydroxychloroquine at the time and the potential to be able to use this drug that was widely available, that was cheap, led to a stalling of various other trials that were on to try to find other treatments for COVID-19. It could be argued that there could have been other treatments that could have come out sooner if it weren't for the focus on hydroxychloroquine at a really key time of the pandemic. And that's something that we reported on at the time as well. I remember speaking to Richard Van Norden, who actually wrote this article in Nature about this very thing back in 2020. So it's a really interesting and fascinating and powerful message about the value of proper research, the value of proper ethical processes, the value of proper peer review, the value of transparency. And with this retraction, which 4.5 years is a long time for a retraction to come out after the concerns have been around for a very, very long time. And it isn't clear why it has taken as long as it has to be retracted, but it has now happened. And now the discussion can be had about why it took so long. We should also add that Raoul and various other authors in this paper are still standing behind the paper and standing behind the findings, but the decision has been taken by the publishers to retract it at this point, and their reasons are laid out in quite an extensive retraction notice.
What are other folk quoted in the article saying then about the wake of this situation, what's been left behind?
So one high-profile person that has been quoted in this story, but who's also been criticising the article for some time and is very, very well known as both a microbiologist, but also as a bit of a sleuth when it comes to research practices to try to expose poor research, is Elizabeth Bick. And she's quoted as saying that this is incredibly good news. She said this paper should never have been published, or it should have been retracted immediately after its publication. I think that various researchers that have been standing up for research integrity here, and this paper has been central to many researchers' concerns, are really pleased that the process has now finally worked and that there seems to be this new focus on ensuring that papers published which have impacts like this are going to be really assessed properly so that we can make sure that the conclusions that are being drawn are appropriate and that they're used in the right way.
We probably should add that Bick and Raoul were engaged in a very public, personal battle and legal battle. Raoul came after Bick in very strong ad hominem terms and legally. So she's not a dispassionate observer of what's happened here, I'm sure. I mean, she was standing up to some pretty big forces as an independent research integrity professional at that time. And actually, she won the award co-sponsored by Nature, the John Maddox Award for standing up for science. And my perspective is that that experience with Raoul did contribute to that her receiving the award.
Absolutely. And we should say as well that this legal action was taken by Raoul against Bick, but then was thrown out eventually, and it was shown that there was no case for her to defend. And yet she did have to deal with really significant forces all the way through this, and she continued to stand up to it for the sake of research integrity.
Well, we often talk about, lessons will be learned, and I think this is one of those. So situations like this don't arise in future. But let's move on today's roundup to our second story. And Flora, why don't you go next?
Well, this story was in Nature and it kind of surprised me. This is about an immune system independent from the one we probably think of when we think of our immune system, which is generated by our skin. So we are just learning that it might be the case that our skin, rather than just being a kind of passive barrier between our insides and our outsides, can actually produce its own antibodies. This was discovered by researchers who took mice that had been raised without any microbes on their skin, and they colonized them with a common harmless bacterium that is pretty much on everybody's skin, all human skin. And what they saw was that there was this immune response in the mouse's skin. And what they were able to show is even when they were actually able to suppress the immune response of the mouse's lymph nodes, where we would think about immune cells coming from, these types of immune cells were still being generated and producing antibodies in the skin. So, okay, this is fine. This shows that this harmless bacterium triggers this response. When it gets really interesting is they modified this harmless bacterium to display foreign proteins. In this case, it was tetanus toxin. They found that the immune response still happened in the mouse's skin, and they were able to give the mice what would have been fatal doses of toxin, and they survived. So the idea is you could perhaps create, let's say, a skin cream that has a vaccine in it. You just rub it on your skin produces an immune response, and that could be useful for all these kinds of new areas where people are thinking that vaccines could be extra powerful. So in our mucous membranes, for example, where we're attacked by respiratory viruses.
I feel like, especially if we've just been over the holidays, it's such a classic trivia question of what's the largest organ in the body. It's the skin, because the skin actually has all of these functions as an organ. But the idea that it has its own immune system, I mean, of course, I don't think we can definitively say it does, but it really grabs me that there is this new approach that we can think about immunology, especially when it comes to vaccines.
Now, we should be clear, this research was in mice, but I think for me, my takeaway message from this was, we're discovering more and more about how our bodies operate as whole systems, rather than the idea that this bit does this and this bit does this, and the immune system seems to be no different. And that seems to me to be a developing perspective on how our bodies work.
I spoke to an immunologist not so long ago for the podcast and started our chat with, it seems to me that the immune system is the most complicated thing in the known universe, to which he laughed heartily and said, yeah, pretty much. And I wonder how much more of it there is to discover.
I mean, it certainly seems like every article we write about human health now, we had another fascinating article actually that readers might have missed over the break, which was about how social isolation and feelings of loneliness, perhaps why they're linked to what we have observed are things like inflammation and immune response. In this case, it was researchers found that certain proteins were associated with social isolation and feelings of loneliness. It seems to be that there's not a health story these days that doesn't involve a surprising immune response. I mean, I guess the next question will be, how do we take care of our different immune functions and make sure that they are protecting us and not overreacting? And I think that probably, I'm sure someone will try to flog some skincare regime based on this article before too long. So, keep your wits about you on that one.
That is a fascinating one. And you're right. Every time we talk about something, it seems like the way that our bodies interact with the world, we're only sort of beginning to tug at that thread. And we shall continue to do so, I'm sure. Let's move on once again. And I've got a couple of stories now, actually. And let's go with a space story next. Now, it is cold here in the Northern Hemisphere on Earth. But I will say it is not as cold as Europa, which is, of course, one of Jupiter's moons, minus a couple of 100 degrees Celsius. And I read a story in Science that was based on a talk given at the American Geophysical Union's annual conference. So not peer-reviewed, underline that. But it's looking at the ice on the surface of this frozen moon and sort of working out how thick this ice might be. And their calculations of what they reckon the thickness might be could be quite disappointing in terms of hopes for finding extraterrestrial life.
God, if I had a penny for every time I said, it's colder than Europa's surface in here, I'd be a millionaire by now. So, not good news for finding life. Tell us more. Why are we looking at the thickness of ice when it comes to finding life?
So the thickness of the ice on Europa could play key roles in things like the cycling of chemicals from the surface to the ocean that's thought to exist underneath. And the thickness of ice could also be related to the heat generated by the centre of the planet. And so if it's really thick, there'd be a low amount of heat. So maybe no hydrothermal vents, which, as we know, are thought to be a key way that life may have developed. But let's back up just a little bit then. So Europa, as I think we're all aware, has been considered, a good spot to look for life. And reading this story, I thought about 2010 Odyssey 2. Do you know this? The sequel to 2001?
Unfortunately, I am unable to read the word Europa without quoting Arthur C. Clarke in my head, as briefing readers will know, because I will often try to sneak those quotes into the briefing.
I knew I was talking to the right crowd here then.
So yeah, as we know, all these worlds are yours except Europa, because it's, according to the alien life of this book, going to be the most likely source for life to arise other than Earth in our solar system.
Absolutely right. You did that word for word. Listeners can't see it, but that was incredible. And so, yeah, knowing how thick this ice is an important part of this, figuring out, could it be a good place? And this work centers on measurements collected using NASA's Juno spacecraft. Okay, that's been orbiting Jupiter since 2016, and it did some flybys of the various moons, including Europa, and it used one of the instruments on this spacecraft, known as a microwave radiometer, to estimate the thickness of the crust. And this is where kind of the potentially sad news kicks in. So where they looked, on average, it seems that this ice was 35 kilometers thick. Now, to put that into some context, the Science article says that this is about 4 times the height of Mount Everest and about 3 times deeper than humans have ever drilled here on Earth. So that could, represent a problem. And 35 kilometers is significantly thicker than other estimates, including one by a researcher who's quoted in the article, who calculated that the top layer might be just 7 kilometers thick, with another shifting layer underneath 13 kilometers thick. So obviously together, still less. So potentially 2 layers. This current work doesn't rule out the 2-layer scenario, but suggests that this second layer would be 35 kilometers down. And this is consistent with where they look. This wasn't just they happened to look at the thickest part of the ice. They reckon that based on the evidence they have, this is a very thick layer of ice.
Okay, so we've got this incredibly thick ice. Does that mean it's the end for dreams of life on Europa then?
Well, thankfully not. You'll have noticed that I said could and estimate and might a few times here, because this is obviously quite difficult to do. There are various caveats to this work, assumptions in the models the team used based on the instruments they had, but it does add to maybe a selection of quite sad Europa news. For example, I remember that a long time ago there were thought to be these kind of plumes, these geysers coming from the surface of Europa that were spotted by the Hubble Space Telescope. The JWST telescope has been pointed there and hasn't found evidence of them. And there are other things there too. So I think the only way to know how thick this ice is to go and have a look. And thankfully, NASA are on that. NASA's Europa Clipper mission is on its way right now to Europa, and it's due to arrive in 2030. Now, it's going to be looking for more evidence of this subsurface ocean that's believed to exist, among other things. And it's going to use radar to look beneath the surface. Now, there is a problem with this too, and would you like me to tell you what it is?
Absolutely.
Radar can penetrate about 30 kilometers, and this ice is believed to be potentially 35 kilometers. So, again, this is just the nature of research, right? They've put forward their evidence. Other people have put forward different evidence. The only way to know what the answer is, or at least to find more evidence of what the answer is, I suppose, is to get out there. But if it does turn out that there is this really thick ice ball, it kind of stymies a lot of other hopes, going out there to land on it, for example. Calculations need to be redone, but also drilling down. I think that's the hope that everyone, including, young me reading 2010 Odyssey 2, drilling down in there to see what was going on. And of course, there are experiments that have gone here on Earth that have looked at ways to try and get into these subsurface lakes without contaminating them. But if you need to drill down for Everests, that is going to be quite the conundrum.
But nevertheless, I've got to say, this is not a downer story. I mean, how exciting to start the year with yet another piece of interesting, fascinating data about our absolute favorite Jovian moon. But the idea that there's a spacecraft already heading there that's going to help find us some of these answers. I mean, this is the kind of thing that is just so fabulously exciting about so many of the space missions that are happening at the moment. And, when things are not feeling so cheerful on Earth, I just love thinking about this kind of pure expression of discovery. And also, if anything, let it remind us that Earth is absolutely the most special place we have. So the fact there's not going to be anywhere soon that's going to be surprising us with life this year, I'm sure. So let's redouble yet again our appreciation of our own planet.
And try to take care of it. There's something also about the nature of space missions, the nature of the fact that these things are so far away and take so long to get to, that people that are making these decisions, space agencies do have to make the decision to send out the next mission now. Otherwise, it's going to take 1,000 years to find anything out. And so there's something about that I kind of love, that there is already this mission en route, that perhaps if we'd heard this already and found out the depth of this ice, they might never have launched that mission. But actually, because they just had to go for it, because otherwise it was going to take too long, it's on the way, so we are going to find out more. And there is never a mission that doesn't give us data. And the more data we have, the more that we can learn. It is a wonderful example of prioritizing learning and prioritizing understanding of our universe. And I think that's just wonderful.
But if they do find a monolith, probably stay away from it. Anyway, let's
no,
keep going.
touch it.
Let's keep going. And I've got another one here, and it's a story I read about in Nature based on a paper in Current Biology, and this was reported in the sort of back end of December. And it's about running. Now, running is often something people take up in January, and if you are listening to us now when you're jogging around the park, you're doing great, keep going. It's something that humans are good at, right? Distance running, endurance running, we are well built to achieve it. But what about our ancient relatives?
I'm going to argue that most of them are better than me, but I do recognise that I am not representative of all humans or indeed all hominids. My thought would be that these days, with our cars and bicycles and such, that we wouldn't have such a need for running anymore. So historically, ancient hominids would be better. But I have a suspicion you're going to say that's not the case.
Well, no, how did you guess? Yes, so this is kind of an anatomy-based story. And in particular, it's looking at Australopithecines afarensis. Now, this is a very ancient human relative and walked on two legs, okay, making this species a favourite for researchers studying bipedalism and how it evolved. But few studies have looked at running, and the reason for that is it requires more than just looking at footprints and looking at bones and what have you. So there's a full anatomy element to this, and mechanics, of course. So what's happened in this work is a team have created a 3D model of the Lucy skeleton. Now, Lucy is the poster Australopithecines afarensis, discovered about half a century ago in Ethiopia, a near-complete skeleton, 3.2 million years old. But on its own, that's not enough. So what the researchers did is they used the muscle features of modern apes and data on the surface area of the bones to estimate Lucy's muscle mass. And then they made a model that kind of simulated Lucy running and compared it to a digital human.
I love these kind of ancient biomechanics studies because it is mad to me that we can take bones and we can end up making something that can move digitally in front of us. It reminds me of when you first see what researchers would think an animal would look like based on just their skin, or when you first see what people think what an animal would look like from just their bones. Trying to reconstruct things from just one element of a body is quite difficult, and yet now we're in a position where we can actually see how something may have walked or run. So in this scenario, how does Lucy run? Is she going to outrun me?
Well, Lucy does run. I think that's an important thing to say, is despite lacking this kind of lengthened Achilles tendon and shortened muscle fibers that are thought to be kind of key to the endeavour of endurance running that are found in modern humans, Lucy could move, but not very quickly, it has to be said. And even remodelling her to give her modern human muscles, she only reached a maximum of 5 metres per second in terms of speed, whereas the human model ran at 8. So I think we're still outpacing her. But of course, Lucy was quite diminutive, and kind of taking that out of the equation didn't help speed her up, suggesting that really physical proportions are key to running rather than just do you have these muscles, yes or no kind of thing.
And also prioritising different ways of living life. I mean, it's been hypothesised that Lucy died from falling out of a tree. That's been done some time ago, and we remember with 3D printing some of her bones, which is how that assertion came about. So perhaps she was spending a lot more time in trees and a lot less time running around.
Yeah, and I think that's reasonable. You're right. There's a lot of evidence that Lucy was probably a good climber. And it seems in this case, further modelling suggests that actually it's the ankle muscles and the Achilles tendon that are really key to enabling modern humans to run for extended periods. But as you say, life was very different 3.2 million years ago. And I think what I'm interested to know is what else could they model Lucy against, right? Like, she would beat me at climbing, I have no doubt. Mario Kart, I think I would absolutely smoke her on that one. But you know, what else can we learn from these ancient skeletons about how our ancient relatives perambulated, I guess.
What I found fascinating about this is I had never looked at Lucy's iconic skeleton and thought, oh, she probably can't run. I think I just imagined she could run. And what this made me think about is how incredible modern humans' running power is, whether we choose to use it or not, or whether we're able to use it or not. I remember New Scientist did a great feature on if there was an Olympics where all species could participate, would humans win anything? And one of the things we would probably win was the marathon. We're just very, very well evolved for long distance running. And this story really threw that into sharp focus for me, that was a journey through evolution that isn't so obvious when you look at our early relatives.
Would we beat like a gazelle? Or like
Over the long, not in the 100 meters.
Yeah. Or like
apparently when it comes to absolute dogged determination, there's this idea, a contested idea to be sure, but this idea that humans hunted by just running the heck out of animals until the animal just could not be bothered anymore. I must admit that doesn't necessarily reflect my daily life, but as a keen runner, sometimes when I'm plodding along, I like to remind myself, this is what you were born to do. Don't give up.
Well, don't give up indeed. I think that's a good place to leave it for this early year edition of the Nature Podcast. For more on those stories, you look out for links in the show notes. And Flora, why don't you tell people where they can sign up for the Nature Briefing to get more of the stories like this delivered straight to their inbox?
Oh, do pop over to nature.com/briefing. And I'd be more than happy to email you a free daily newsletter with the best of science from nature and abroad.
Well, Noah and Flora, thank you both so much.
Thank you so much for having me, Ben.
You're very welcome.